So we want to take the indefinite integral of 4x to the third over x to the fourth plus 7 dx. So how can we tackle this? This seems like a hairy integral. Now the key inside here is to realize that you have this expression x to the fourth plus 7, and you also have its derivative up here. The derivative of x to the fourth plus 7 is equal to 4x to the third. Derivative of x to the fourth is 4x to the third. Derivative of 7 is just 0. So that's a big clue that u substitution might be the tool of choice here. I'll just write I'll write the whole thing. U substitution could be the tool of choice. So given that, what would you want to set your u equal to? And I'll let you think about that, because if you can figure out this part, then the rest will just boil down to a fairly straightforward integral. Well, you want to set u be equal to the expression that you have its derivative laying around. So we could set u equal to x to the fourth plus 7. Now, what is du going to be equal to? Du, I will do it in magenta. Du, well, it's just going to be the derivative of x to the fourth plus 7 with respect to x. So 4x to the third plus 0 times dx. I wrote it in differential form right over here, but it's a completely equivalent statement to saying that du, the derivative of u with respect to x, is equal to 4x third. 4x to the third power. When someone writes du over dx like this is really a notation to say the derivative of u with respect to x. It really isn't a fraction in a very formal way, but oftentimes you can kind of pseudo-manipulate them like fractions. So if you wanted to go from here to there, you could kind of pretend that you're multiplying both sides by dx. But these are equivalent statements, and we want to get it in differential form in order to do proper u substitution. And the reason why this is useful, and I'll just rewrite it up here so that it becomes pretty obvious. Our original integral we can rewrite as 4x to the third dx over x to the fourth plus 7. And then it's pretty clear what's du and what's u. U, which we set to be equal to x to the fourth plus 7. And then du is equal to this. It's equal to 4x to the third dx. We saw it right over here. So we can rewrite this integral, and I'll try to stay consistent with the colors, as the indefinite integral. What we have in magenta right over here, that's du. Du over, try to stay true to the colors, over x to the fourth plus 7, which is just u. Or we could rewrite this entire thing as the integral of 1 over u du. 1 over u du. Well, what is the indefinite integral of 1 over u du? Well, that's just going to be equal to the natural log of the absolute value. And we use the absolute value so it'll be defined even for negative u's. And it actually does work out, and I'll do another video where I show you that it definitely does. The natural log of the absolute value of u, and then we might have had a constant there that was lost when we took the derivative. So that's essentially our answer in terms of u, but now we need to unsubstitute the u. So what happens when we unsubstitute the u? Well, then we are left with, this is going to be equal to the natural log of the absolute value of, well, u is x to the fourth plus 7. X to the fourth plus 7, not c, plus 7. And then we can't forget our plus c out here. And we are done.